Well, hello everybody. We're going to go over the first 4 questions on the chemical reactions review here. So question number 1, what is Avogadro's law? Well, that's the law that says equal volumes of gases have the same number of molecules. It's not Avogadro's number. Equal volumes of gases have equal numbers of molecules. So if you have 1 liter of nitrogen gas and 1 liter of vapor, steam, water, they will have the same number of molecules. Later on, in Avogadro, this was a big deal. Later on, when they figured out when they refined the idea of the mole, they figured out that 1 mole of a gas has Avogadro's number, which is 6.02 times 10 to the 23 molecules. But Avogadro didn't know the number, but he knew you have 3 containers of gas. Let's say this is helium, same size. He was able to figure out there's the exact same number of molecules in there. That was pretty big. Now let's see, what can the coefficients in the following equations stand for? Well, in this problem here, they're telling you, we can look at it 2 ways. We can say 2 molecules, so that means it's a multiplier. There's 2 molecules of ammonia, and they will react to form, now there's not a 1 written there, because they don't bother to write ones, 1 molecule of nitrogen gas plus 3 molecules of H2 gas, hydrogen gas. Now, when we're also in chemistry, usually chemists will say, when we're talking about the idea of the mole, that if you take 2 moles of ammonia and H3, it will break down into 1 mole of nitrogen gas and 3 moles of hydrogen gas. So you can either say that these are 2 molecules reacting to make 1 and 3 molecules, or that we got 2 moles of ammonia forming 1 mole of nitrogen and 1 mole of NH3. So the coefficients are telling you how many of the molecules are there. What is conserved in a chemical reaction? Conserved means to save. In this context, it really means that you can't create or destroy anything. So in a chemical reaction, first off, mass is conserved. You can't create or destroy anything, which in chemistry means, well, like for this problem here, up there, we've got, let's see, in this reaction we've got nitrogen and 3 hydrogens, so 4 atoms, but 4 atoms times 2 is going to be 8 atoms. So there's 8 atoms over here, and when we come over here in the products, we've got, let's see, 2 atoms here in nitrogen, plus we've got 3 times 2 is 6. 6 plus 2 is 8 atoms. We're not creating or destroying any atoms. So mass is conserved, which means the number of atoms is conserved. They have to be the same. You cannot, oh, I'm sorry, that was pulled off there. So the mass is not changing, which means the number of atoms aren't changing. Now, we're going to get them in different form. They're going to be different molecules. You can get different molecules formed, but you're always going to end up with over here, as far as atoms, you're going to have the same number of each atom over here. They're just teamed up different. All right, let's see. Number 4, we've got this balanced equation, 2KClO3, and I'm going to go ahead and just put parentheses around those. I don't think we're doing any, we're just doing stoichiometry kind of problems here. So this first question is, this says 2 moles of potassium chlorate change into 2 moles of potassium chloride plus 3 moles of O2. Now, if you're not sure which is KClO3 and KCl, then you can get on your phone and you can say potassium chlorate and look it up if you weren't sure. So in this problem here, I recommend you need to have your MVP triangle on the test. You're going to want to make sure you've got this written out on your practice page. But we're going from how many moles of potassium chlorate are needed to produce this many moles of oxygen, 1.5. So this is our given. This is our given. And we're trying to find this. And this is where I'm telling you in the problem. Okay, actually I'm going to do this in pencil now so I can erase later on. Let me get my pencil. Okay, so moles of oxygen here, these are the given. And we're trying to find potassium chloride. I'm just going to write find in pencil on this. So the given in the problem, we're always going to start 1.5 moles. I abbreviate mole, just MOL. Now it's oxygen gas, and in the balanced equation, O2. Oxygen is in the form of O2, so you need to make sure to put O2. And we're going to put that over 1, because we're just going to put always the given like that. So when we look at our MVP triangle, we're starting at moles of oxygen, and we want to end up at moles of potassium chlorate. Which means when we look at the mole triangle, we're going to start, and I'd say, okay, we'll call this O2, and we're trying to find potassium chlorate, which is KClO3. I'm just going to write that in pencil on there so I can see that visually right there. Now, all we have to do to go from moles of oxygen to moles of potassium chlorate is to take our given, and then we need to multiply it by this, by the moles of compound B, which is KClO3, but you have to look at the balanced equation. So we want moles of KClO3 on the top. So over here, we're trying to find KClO3. We've got 2 moles in that balanced equation. 2 moles KClO3. That was a horrible looking 3. And we got to divide it by the moles of compound A, which is oxygen, which I already labeled up here. We're the given. And there's 3 moles of O2. 3 moles of O2. Now, you want to double check. I make this mistake all the time when I'm working with students sometimes, but this is the way I check it. If I can cancel this with that, I've set it up right. Now, in your calculators, you would do 1.5 times 2, then divided by 3. I'm not going to give you the answer there. You can work that one out. Now, in part B here, how many moles of oxygen gas would be produced? So that's what we're trying to find this time. So I'm going to come over to my balanced equation. I'm going to erase this, and I can say now this time we're trying to find oxygen in the form of O2, find, and we're decomposing 5 moles of KClO3 in this problem. Okay, so now we're trying to find this one. So we just kind of change them around. We're given this amount, so this is our given. Okay, so this time, let me make sure I haven't messed it up. How many moles of oxygen, that's what we're trying to find, and I labeled oxygen find, will be produced from the decomposition of 5 moles of KClO3. So that's our given. We're going to start off by putting that over 1. 5 moles of KClO3. I know it's a pain, but I need you to set that up. And let's see, according to our MVP triangle, we're doing the same thing we did before. Right now, we're just going from moles of, and I think this time our given was KClO3, and this time we're trying to find O2. O2. So when I set up my mole ratio, compound B, moles of compound B from the balanced equation. All right, well, we're trying to find, this was our given we said, we're trying to find, there we go, yeah, we're trying to find the oxygen. There are 3 moles of oxygen in the balanced equation up there. So we're going to, for our mole ratio, 3 moles of O2, and the given in the problem, because we want to divide mole ratio by moles of compound A, which is moles of KClO3, from the balanced equation. In the balanced equation up there, we have 2 moles of KClO3, 2 moles of KClO3. Now this is where a lot of students say, no, the problem says there's 5 moles. Well, that's our given for the problem. That's what we're starting with. But when you do the mole to mole ratio, it is only looking at the coefficients in the balanced equation, and that's what you got to remember. Balanced equation there. Now, if I could cancel moles of KClO3, cool, with moles of KClO3, I've set this up right. So now in your calculators, you're going to do 5 times 3, and then divided by 2. You probably don't even need a calculator to do that one. All right, so part C. Okay, what we're doing here, we're just having you practice some of these different changes. Right now, these are all just mole to mole ratios. How many moles of KClO3 need to decompose to form 11 moles of oxygen? So this is our given, because they're telling us there's an actual number, 11 moles of oxygen. So this is our given. Up here, okay, we're going to change now, and I'm going to label that oxygen is now our given. And we're trying to find KClO3, so once again, we're changing that around. This is now the find. That'll help us in a moment. How many moles? This is find. It's our given. So we always start by the number that was given to us in the problem, and it's 11 moles of oxygen gas. Oxygen gas is O2, and if you're not sure, you look up there, divided by 1. So now we need to do, we're just doing again the mole to mole ratio. We're going to jump from here. This time, let's see, our given is O2, changing that around. That's why it's really nice to use a pencil for this. We're doing KClO3 again. So we're just having to do the moles of KClO3 from the balanced equation on the top. We got 2 moles of KClO3 and moles of O2. Yeah, we got to divide by what was given. We got 3 moles of O2. That's looking good because I can cancel the 3 moles of O2 with the moles of O2 from the problem. And now we're going to have 11 times 2 divided by 3 will give you your answer. So in this one, now we're doing an extra little step right here. How many liters of O2? So that's what we're trying to find. Okay, we're trying to find liters of O2 from the decomposition of 1 mole of KClO3. This is our given. 1 mole of KClO3. And so when we look at our MVP triangle, we're trying to find, now this is the find side, we're trying to find this. We're trying to find volume. So at some point we're going to have to probably convert this, and we're starting with 1 mole of KClO3. So we're finding oxygen. So I'm going to label this side now, erase away the find. We're trying to find oxygen. And, they're excited outside there. And the given in this problem is KClO3. So we got, our given is 1 mole of KClO3 over 1. Okay, that's just our given. Now, so what we're going to do is, this one's a little more involved. We've got to do the mole to mole ratio. Then we need to multiply by 22.4. So the moles of compound B, O2, from the balanced equation. Let's see, from our balanced equation up there, we had 3 moles of O2. In the balanced equation, we had 1 mole of KClO3. You got to put that on the bottom. Excuse me, we had 2 moles. KClO3. Now let's where I check. Moles of KClO3 cancels moles of KClO3. Now we got to do one more though, because now we've made the jump to moles of O2, but we want liters of O2, so we need to multiply by this fraction here. We need 22.4 liters over 1 mole. 22.4 liters of O2 is 1 mole of O2. If that cancels with that, we've set it up right. So now you're going to have, okay, well, we don't need to bother to multiply by 1. We're going to have 3 times 22.4 divided by 2. So here ends that one.